Alright, welcome back boys and girls. It's your main math man, Mishank, coming to you live from Alameda International High School. In this video, working through that test numero trace. Very similar to that systems quiz that we took, but we can kind of go back over it and see how it works. So on this first page, we have two linear functions, and what we're going to do is we're going to go ahead and graph them and see where they intersect, meaning find that solution point. And then at the bottom, we're going to substitute, meaning plug in those values for the variables and check to make sure that it is a true statement. All right, so one thing at a time. So let's first graph these equations. Again, always in the form y equals mx plus b. Again, y-intercept is where we start. So again, that's the point 0b. So again, start here first. And then use the slope to determine how many steps that you're going. So that, again, this is the slope. So we're going to say, if this is the slope, we're going to say change in y over change in x. So if it looks something like this, again, I have my first equation, y equals negative x plus 3. Again, I can take that plus 3 and I can say, hey, that's going to be my first equation. I got to make sure you can kind of use two different color pencils. That way you can have those two different equations. And then I can say, all right, anytime I have my slope as a integer, I can write it over 1. So I can rewrite it like this. I can say, all right, my slope is going to be negative 1 over 1. That just means one step down for every step to the right. So again, make that pattern for yourself. I can go one step down, one step to the right, draw a point, one step down, one step to the right, draw a point, so on and so forth. So each of those steps, again, makes that staircase, but if you notice, it should be in that straight line through those points. Once you have that straight line, again, go ahead, take your straight edge or ruler and draw a line through those points. All right, it's been doing this since we started back in November, but always make sure you can still do it. All right, for that second one, let me maybe do it in red. And I'm gonna say, all right, I have my y-intercept at 5. So I'm gonna say, plot the point 0, 5. So that's on the y-axis, has to be on the y-axis. So I'm gonna plot the point 0, 5. And now I can say, all right, this is going to be my slope. So I have my slope as negative 5 over 3. That means I go 5 steps down for every 3 steps right. And again, make sure you're doing both of these before you plot your next point. A lot of people are going 5 down, plotting a point, going 3 right and plotting a point. Make sure that you are doing both, then you plot the point. So I go 1, 2, 3, 4, 5 down and 3 to the right. 1, 2, 3. And if you notice, hey, I already have a point there, and so that's probably going to be where they intersect. And so I'm going to say, all right, I have my 2 points, draw that line through those 2 points. So something like this. Again, do take your time as you're doing it, that way it's nice and accurate. And so I'm saying, okay, where's that point of intersection, meaning where do they cross? I'm going to say, hey, that's going to be where my solution. So intersection point. That means this. These two lines are equal at this point, meaning the solution to this system is going to be the point 3, 0. Again, always writing your ordered pair as an x and a y value. Then for that part C, all I have to do is take this values that I have for x and y, and I'm going to plug those into my equation. So I'm going to say 3, 0 and 3, 0. So again, make sure that you're simplifying carefully. So I have like this, I rewrite this equation. Instead of y, I have 0. Instead of x, I have 3. So I'm going to say 0 equals negative 1 times 3 plus 3. And I'm looking, let me actually write it up here. I'm looking for a true statement. That means I want the left side to be equal to the right side. And so currently right now I have on the left side 0, on the right side I have some values, and so I'm trying to say, all right, I want this entire right side to be equal to 0. That way I know that this is a point on this for this equation, and more importantly, where the solution for the system is. So I'm going to say, all right, -1 times 3 is going to be -3. Everything else stays the same. -3 plus 3 is 0, which is equal to 0, and so I'm good. So I know that I was on the right track for this equation. So again, this is that check part, checking to make sure that both sides are equal. Same idea for your next part or your next equation. When y equals 0, we're saying this equation should have x equals 3. Now a lot of people are getting stuck on this part. Again, make sure you can let me actually circle this a little bit. And I'm gonna say, all right, I can take and I can write it like this. I can say -5/3 times, and then I can have 3/1. Make sure you multiply the numerators together. So I have -15 over and 3, which is the same thing as -5. And so what I can do instead of these parentheses, I can say 0 equals, and I have -5 plus 5. So all I said was I multiplied those values together, and I got -5. And now I'm trying to make sure that my right side is equal to my left side. So I'm going to say that 0 equals 0, and so we're good. On the back, similar setup. I can say, all right, I have two equations. Make sure you start at the y-intercept, so I'm going to start at -2. So I plot the point 0, -2, and then I'm going to say, all right, I have the slope of 1/4. I have my slope 1/4. That just means I go 1 up and 4 to the right. So from this point, I go 1 up, 4 to the right, 1, 2, 3, 4, and plot it. Again, make sure you're using those values or numbers on the coordinate plane. That way it helps you guide them. But if you can, try to keep going. That way it makes that pattern for yourself, and that way it's a little bit easier to draw the line through those points. Also, if you wanted to go to the left, I could say I can go down 1 and to the left 4. To get my next point, down 1 to the left forward, get another point. So notice how it's the same pattern each time. Once I have my points on the graph, again, make sure it goes through the corner on those integer values. Again, goes through those points. That way I'm good. On the next one, I have y equals 3/2 times x plus 3. So I'm going to start the y-intercept of +3. So on the y-axis, I find +3, graph that point because it's 0, 3. And then I can use that slope, so that just says 3/2, which is 3 up and 2 to the right. So again, from this point, I can say I have 3 up, so 1, 2, 3, and 2 to the right, 1, 2. Once I have those 2 points on the graph, I can draw my line, but I want to be a little bit more careful, so I can still go up 3 to the right 2, or I could go down 3, 1, 2, 3, and to the left 2, and I can get more points on the graph. And if you notice, hey, I have this pattern that goes through those points, and more specifically, it hits at that point as well. So 1, 2, 3 to the left. Okay. So notice how it has that pattern for us. I can draw that line through those points. Again, do take your time when you're graphing them out. So it should be in that intersection point. And so I'm going to say this is the point where they meet. So that's our solution to this system. So I'm going to say, what's the x value? What's the y value? Well, I have -4 and -3. So I'm going to say -4, -3. What type of solution? Well, they cross at one point. So that just means one solution for this system of equations. And then for this part D, I can say, all right, why did I pick one solution, or how do I know it's true? Well, I can say these equations / lines meet or intersect at one point. This means that the system has one solution. Again, it's one of those three choices. It either has one solution, meaning it crosses once, it has no solution, meaning they're parallel, meaning they don't cross, or it has infinitely many, which is when they are the same line. So this is, let's say, parallel lines is for no solution, and this is for same line, meaning same slope and same y-intercept. For the next page, now working with those systems, but we're now working with substitution. So again, make sure you're reading directions. Substitute one of those equations in for the other and solve for one variable. Then substitute that value into the original equation. Lastly, write your solution as an ordered pair, x and y. So now I can say, all right, what I can do is I can take this entire expression, x plus 2, and I can replace it, meaning substitute for y. And I can take and I can plug it into my other equation for y. So instead of y, I'm going to write this in parentheses. So make sure you write in parentheses. So when you substitute, make sure that you have an equation in terms of one variable. That way you can know you substitute correctly. So if I kind of wrote this again, or I wrote this equation after I substituted and I have an x and a y, I know I messed up. So I'm going to have this. I'm going to say, all right, I have 4x minus, and I have 8 times. So use those parentheses, show multiplication. So I have x plus 2 equals 4. Make sure you can use your distributive property. So on the side here, I can write I have -8 on the outside, and I have x on top. So I have 1x positive, and I have positive 2. Make sure you multiply these together. So I have -8 times 1x is -8x. And then I have -8 times positive 2 is -16. Now I can say, okay, what I wrote in the box is what I can replace with those parentheses. So everything else stays the same. So I have 4x minus 8x minus 16. There we go. Minus 16 equals 4. Trying to combine like terms and solve for this variable x, so that I have 4x minus 8x is -4x. Everything else stays the same. Get that variable by itself, I'm going to add 16 to both sides, and so I have -4x equals 20. At the last step, make sure you can divide both sides by that coefficient. So I divide both sides by -4, and I'm going to say x equals -5. Once you have your value for one of the variables, again, substitute back into that original equation. So what I can do is this. I'm going to take this value of x, I'm going to place it, let's be careful here, I'm going to replace it or substitute it into that equation. Again, you can substitute it into this equation too, you'll get the same answer, but again, keep it simple for yourself. So I'm going to rewrite this equation. Instead of x, I now have a -5. So I say y equals, and then I have -5 plus 2. Real simple, do one step. -5 plus 2 is -3, and so that's what I say y is equal to. Once I have my two values, x and y, I can write my ordered pair. So I'm going to say my ordered pair is going to be -5, -3. For the second equation, similar setup. I can say, all right, I'm going to take, and this is actually from the notes, so this is from substitution notes. This is actually example 1. So very similar setup, and it will actually give you the same solution, but it works like this. All right, I have my two equations, and what I can do is this. I can replace one of these variables for one of the values. So I could say, all right, I have y equals something and I have x equals something. So it's up to you what you choose or want to substitute, but as long as you are doing it carefully, you'll be fine. So let's say this. I can say, let's do, instead of x, I now have this. So I'm going to say, all right, I have y equals, I have 2 times y plus 3. Make sure you can solve for your variable y first. So I'm going to say y equals 2y plus 6. And make sure you're multiplying that term from the outside of parentheses times each of the terms inside. So that's how I got 2y plus 6. Now I can say, all right, I'm going to get y by itself, so I can subtract y from both sides. And so I have 0 equals 1y plus 6. Subtract 6 from both sides. And so I have negative 6 is equal to y. So that means, again, x, once you have an x and a y value for that ordered pair, so I have negative 6. So now what you can do is this. I can take that value, plug it back into my original equation. So I can say, instead of y, I have negative 6. So I have negative 6 plus 3 equals x. That just means x is going to be negative 3. Again, real simple. Make sure you saw how it looked in the notes. Same exact problem because it's the same solution. And then on the back, on the last page, it has some elimination. So using those ideas for substitution, we're now going to have to multiply, at least one of these equations by a value, so that way you can get opposites. So what I'm going to do is this. I'm going to, let's multiply. I'm going to multiply this equation by a -1, so that way I can have opposites for my y value. So I'm going to take this times a -1, and so the way it works is like this. I'm going to say I'm going to rewrite it down here. So I have negative 1x, and then I have plus 5y equals positive 18. So notice how I multiply each of the terms inside the variable, or inside the parentheses, excuse me, and now I can just add these columns together. Again, trying to eliminate one of these variables. Notice how the opposites for the y terms are there. And so I have 2x, y's cancel out, equals 4. Negative 14 plus 18 is positive 4. Divide both sides by 2, and I have x equals 2. Once I have that value, take and plug it back into the original equation. So I can say, instead of x, I now have 2. So I'm going to say 2 minus 5y equals negative 18. Trying to get y by itself, I can subtract 2 from both sides. I have negative 5y equals negative 20. Divide both sides by that coefficient, so I divide both sides by negative 5, and I can say y equals positive 4. So that means my solution, x and y, is going to be the point 2, 4. Again, make sure you're multiplying at least one of these equations by a value, so that way they are opposite. So if you wanted to, you could have multiplied this by a -3 and canceled out the x values, but I wanted to keep it simple, so I multiplied the equation by a -1, so that way the y's canceled out. All right, and for the last one, this was, let's say, from assignment 3-7, and it was from 3-7, number 1. And it should be a positive 11, so make sure if your paper says a -11, it should be positive 11. So a little bit of a typo, but that's okay. You can still set it up carefully. So what I'm going to do is this. I have some options here. I could multiply this first one by 3, because then it would have my y values would be opposite of each other, or you can multiply the second equation by -3, so that way your x values are opposite of each other. And so that's what I'm actually going to do. I'm going to multiply this by a -3. So multiply by a -3. So I'm going to rewrite it under here. So I have -6x minus 9y equals and then negative 21. Now I can add my columns together. I'm going to add my two equations together. So I have 6x and negative 6x. Those cancel out. Then I have negative 10y, since this is just a coefficient of negative 1. And then I can say this is going to be equal to negative 10. Simple step, divide both sides by the coefficient. So divide both sides by negative 10, and I have y equals 1. Once I have that value, plug it back into one of the original equations. And so I can say, all right, instead of y, I now have a 1. So I'm going to say 2x plus, and I have 3 times 1, because that's my y value, equals 7. Make sure you can multiply, so this is going to be 3. Everything else stays the same. Two-step equation, I subtract 3 from both sides. And so I have 2x equals 4. Divide both sides by 2. And I could say x equals 2. Once I have my two values, x and y, I can write my ordered pair for the solution of the system is going to be 2, 1. Again, make sure you can, if you're doing corrections, be sure to do it on a separate sheet of paper, staple it to the original page, and make sure your name's on it. Be sure to ask questions if they come up, and as always, super slam that subscribe button.